Morning. My name is Jim Armstrong. I'm the department head for the Advanced Industrial Control Center here at BCIT. This morning what we're going to do is we're going to go through a pulp blending process that we have here in our industrial instrumentation lab. So we have this graphics overview which is coming from a distributed control system, and Ray, if you swing around and catch Mari, Mari is actually sitting on the server computer, and those graphics are actually coming up from a camera and being shot back onto the screen. Okay, great. You can practice quicker. So the process itself is we're going to go through this morning and make a batch of pulp in here, and we have a repulper where we're going to load in sheets of pulp stock, and it takes 80 sheets and about 170 gallons of water in here to make up around a 3.5 to 3 3/4% consistency pulp stock. Then we'll dump it into a heavy stock tank, and it takes 8 batches to load this whole system up. We're going to start off with heavy stock in here, which will typically be running 3.5 to 4% consistency. We're going to run it through a stock pump. We're going to add some white water to it. So we have a tank of white water here, and white water will be added into the stock line. The pump will mix it, and then we'll end up with stock coming up. We're going to circulate it back through a pressure control loop using letdown control to maintain the pressure at exactly 20 psi. Then we're going to take that stock, we're going to hit it with more white water. So there's white water coming across this line here, comes up, mixes with the stock, and we're going to knock it from 3.5% consistency down to 1.75. And typically we'll have 75 or 100 gallons a minute of stock going into our light stock tank. Consistency meter will be monitoring that and actually controlling the addition of white water to maintain the consistency at 3.5%. And to give you some idea, if there was 37.5 gallons a minute, US gallons a minute of stock coming in here, and 37.5 gallons a minute of water coming in here, the 3.5% stock would get cut in half down to 1.75%, which is what we're actually targeting for. We now take some of that 1.75% stock, shoot it back up here, and at this point we take some of the 3.5 and we actually blend it with the 1.75 and create a 2.65% consistency. Again, mixed. Stock comes over here. We hit it with more white water, knock it from 2.65 down to 2.2% consistency. From there it goes over into a head box, over a side hill screen, and I said side hill, and the stock goes back into this tank. It gets dewatered as the water goes through the screens. Doesn't show on this drawing very well, but I would confuse it with 2 lines, but the water that collects behind the screen here and the water that collects behind the screen here are both drained back into the white water tank. Hence, it is a closed loop system. So, Mari, would you get me the graphic of the batch repulper? Thank you. So this is the control strategy for running the repulper. It's running on something called the sequential function chart. It's one of the 5 IEC 1131 languages, and Emerson did a really nice job, or Delta V did a really nice job of laying this out graphically. I like it. We have what are called steps, and in steps we do things like we turn on a pump, or we open up a solenoid valve, or there's some sort of activity or action that we do. And then we have transitions, and to be able to move from one step to the next, you have to go through a transition. So graphically, looking at the actual module itself, right now we're sitting up here, and we've been sitting for a long time, like 3,200 seconds. It's been waiting here. And we're sitting and waiting for a start command, and we'll get a start command in a few moments. Then what we do is there's a little, what looks like a little calculator here, and they've got this is a transition. It's waiting for the start command. Once it gets it, it's going to move down to here. It's going to send some messages out. And then it's going to wait to see if there's enough level in the tank below to make sure that we can open up the dump valve and dump it. And Mari, would you go back please to the graphic, the operating graphic? So, and would you now click on the repulper please? Thank you. So over here in my repulper, it's basically waiting for us to push that start button. We're not going to do that yet. It's telling me what step numbers it's at. This is the message that it's sending out at this point, telling us it's waiting for a start. And we also want to know how many sheets to put in there. So as we're adding sheets, we're going to get a sheet count coming in. This is water solenoid, this is an agitator, and this is the dump valve. So what it's waiting for right now is it wants to make sure that there's enough room in this tank. Well, the tank's empty right now, there's nothing in it. This blue line in here gets a dark blue color coming up as it begins to fill. So there's nothing in the tank. So Mari, if you'd go back please to the sequential function chart. Thank you. And so what will happen is this thing is going to step to this next point where it opens up the valve, and then it's going to hold the valve open for 10 seconds. It's then going to check to make sure that the repulper is empty, and if it is empty, then it'll move on. So yeah, just keep cycling down, that's great. It'll close the dump valve, then it's going to pause for 10 seconds. Then it's going to open up a water solenoid valve to add some water in. Then it's going to interrogate. The transition is looking to see if we've got 170 gallons of water in there. Once we've got that, it's going to start the agitator. Once the agitator has been started, it's going to now wait until we have got 80 sheets in there. So we are going to be taking and pushing a button up there for each sheet that we put in. Once it's got 80 sheets, then it waits for another 300 seconds or 5 minutes, basically mixing the stock. Once it's finished that, it stops the agitator, and then what it does, it interrogates to see if there's room in the heavy stock tank, and basically it's making sure that it hasn't got anything more than 1,500 gallons in it. It'll open up the dump valve, which is going to dump everything out. Then what it does is it checks to see what the level is in the repulper, and if the repulper is empty, it's to close the dump valve, and then it simply goes all the way back to the beginning and waits for us to start again. Okay, so Mari, would you just scroll up so we're at the top? And what you can see right now is we're waiting for a start. So Mari, on the other screen behind you, no, this screen over here, I've got another one open up. So just do a start on that repulper, will you? Okay, so you can see she started it, it jumped all the way through here, it's opened the dump valve, and it's waiting for 10 seconds, and now it's again. So Mari, if you go back to the other screen and scroll that up. So that's good. So now it's closed the dump valve, and now it's waiting to open up the water solenoid. And right now we've got the block valves closed upstairs, so it's not going to do anything. It's basically stuck here. One of the things that we can do is we can actually force transitions, and it's something we could do when we're testing. The other thing that we can do is we can simply hit the abort button. So right now it's here, and if the abort button gets touched at any point in time, it'll go right through and back to the beginning. So if you would hit the abort button on that operator screen, please. You see that it's gone right back around, and Mari, go back to the top of this module graphic. This is called Control Studio, by the way. And you'll see that we're at the beginning and we're waiting for a start. So what we're going to do is we're going to leave here now and go upstairs and open up all the necessary valves. Okay? So right now Mari is closing off the stock valve coming out of the bottom of the tank. And then what we're going to do is we're going to also close this other valve that's going down the sewer. Okay, so the next thing that we need to do is we need to turn on the necessary disconnects on the motor control center. And so Mari, if you would get, first of all, we're going to need agitator 5.1. Okay, so if you would turn that on, please. And yeah, that's great. And the rest of these we will need later, so let's turn on agitator 5.2 and 5.3. These are the two big agitators in the stock tanks. Okay, so that's all we're going to need for making up the batch. Later on, behind you, we're going to actually turn on pump 5.1 to be able to transfer the stock over to the from the heavy stock tank to the light stock tank. And so we might as well turn on that disconnect now. Yep, okay, so let's head upstairs. So this is our repulper, tank 5.1, and down underneath the bottom of it, you can't see it because it's on the floor below us, but there is a valve down there. That's the dump line itself. It's going to go dump it into the stock tank. Over here, we've got fresh water coming in, and Mari, if you can reach that valve up there, please. Wide open and back 1/4 turn. So the valve is the back seat. This is the solenoid valve, which because we had that valve closed, that's why the program did not proceed, because there was no increase in level in this tank. The tank is actually running on a load cell, and Ray, if you can catch the load cell itself. That's the load cell. And the load cell is measuring this tank because the tank is actually on a hinge. So Ray, if we come back out, we've got a hinge where my laser is pointing right now, and so the whole tank is swinging back. And if we move back out a little further, Ray, I want to get this guy up. So here we have a level transmitter, which is measuring that load cell, and as the weight increases, the load on the load cell, the actual steel cylinder that's sitting in there, tends to compress maybe a half a thou, and we've got strain gauges inside that load cell, and so therefore it measures what the weight is of the tank, and from that we infer how much water we put in. 1 gallon of water is 8.3 pounds, okay, and so therefore we're putting in 170 of them, so multiply it, and that's the change in weight. Okay, we're done with that. Now, so we need gland water for the agitator. So Mari, if you would turn that valve on, please. And the agitator itself is underneath this little platform, and there is a water line which is going into there from the other side. And there's a rotometer right here that I've opened up a little bit, and I've got it set down just so it's barely open. Barely open. Okay? All right, now, if you can get Raven, if you can go up that stairwell, take a look inside the tank. If you look into that tank, you'll see an agitator, a propeller in there, and that propeller is going to be turning later on, and that's what's going to mix our stock up. Mari is going to be loading sheets in here, and when she loads the sheets in, she'll put them in behind the agitator blade so that they actually get pulled through the agitator and get broken up. Now the stock sheets themselves are over here. So this is pulp stock that we get from one of the mills donated, and these sheets are coming off of of a pulp dryer, and they actually get slitted this way and then sheared. Once they get this much of the sheet, there's a big shear comes through, and you can actually see the shape of it. If you look carefully, I don't know how well this will show on there, but there's little marks in here, and that's the actual wire on the floor drainer where the actual sheet was formed. It's the shape of that wire. Anyway, we're going to take these sheets, we're going to basically fold them in half, flatten them down so they kind of go in behind the agitator blade a little bit better. Okay, so we're going to basically get a bunch of these over the other side and ready to go. So we're now at the point where we're ready to start putting pulp into here and start this process up. So Mari is going to go downstairs and start it, and what will happen is that before she gets back here, you're going to hear the dump valve open and close again. Then you're going to hear the water solenoid come on, and we'll actually get a picture of the water being added in there up to 170 gallons. Okay, Mari, you can start at any time. Okay, the valve has just opened up. I'm assuming you're videoing that? Yep. And in 10 seconds, less than that now, it goes back on. So the next thing that should happen is that we're going to open up the water solenoid. Get to 170 gallons in there. Once we get to 170 gallons, it will start the agitator. So the next step in this process is to now add 80 sheets. So for each sheet that Mari puts in there, I'm going to push this little button, and it's got to turn green in color when I push it, so that the DCS downstairs can count the number of sheets that are going in. So the technique is that she puts the sheet in behind the agitator blade, and the first ones go in real easy. So that's sheet number 1. So Ray, if you just catch me. One sheet has now been added. So now I'm going to add sheet number 2 has been added. Sheet number 3 is in. And they go fairly fast. I don't know whether you can hear the thumping in there, but listen when that sheet goes in. That little thump that was there is the sheet getting pulled through the blade and getting cut. So we've got 8 sheets in there right now, and Ray, if you just want to go up there and get a picture of what stock looks like, it's pretty fluid. A lot of water and not very much. So we're 1/10. Oh no, I'm sorry, we loaded 10 out of 80 sheets. As Mari begins to load in the sheets later, they're going to get harder and harder and harder to get in there. Begins to get a lot of stock in the slurry. When we talk about consistency, it's the amount of fiber in the slurry. So a tree naturally standing in the field would have 50% consistency because it's 50% water and 50% cellulose fiber and tar and lignin that's holding the fiber together. I could hear that agitator slowing down a little bit because that stuff's starting to get thick, and now you see Mari's having to push those sheets in. Okay, so we've got half of the sheets in right now. Ray, just take a picture of what it looks like. And that's probably around 1.7, 1.8% consistency. It looks pretty thin. Okay, when we get the next 40 sheets in there, it's going to thicken up a lot. So, Mari, how much time are you allowing between the sheets now?
Probably 20 seconds, and I can see the surface slowing down through its circulation with the agitator.
Okay.
And then it speeds up once the sheet has gone through.
Good. Okay, so now you've got an idea of what you've got to look for. And Ray, if you can just get a shot of that right now, you've still got another 10 sheets or so, but you can see the one that she's putting in right now. She really got to give it a push down to get it into the actual slurry itself, and then she's waiting to actually see it circulate through the agitator and come back up the other side. Okay, so Mari's going to put in the last sheet. I'm not going to push the button until that sheet is stuck down inside. When I hit this button and it counts 80 sheets, it's then going to go into its 5-minute mixing cycle. So we can go ahead and put that sheet in now. And now that it's under the surface, some mixing going on in there, and I'm going to hit this button now because it's going to add an extra 5 minutes on here when it's going through the mixing. So it should now start its internal timer to count for 300 seconds. Again, around 4% consistency, between 3.5% and 4%. Later in the video at the end, we'll show how a sample is tested. But we would take a sample of that and run a consistency check on it and see. Okay, we're moving. Dumping the valve or dumping, and it's waiting until the level goes to 0, and then it closes the gate valve back off again. And so Ray, you should be able to see just the gate valve down in there. It should be closed. Okay. All right. So we are basically done. Mari asked a question a few moments ago because I made a comment about a Presto log, and I want to go over to a pulp line over here and take a quick look at this. Where is Mari? So one of the concerns that we have is that when we shut down at night, we've got to make sure that we get all the pulp out of the lines. If we don't, it could end up hardening in there. And if it did, it could do damage to some of the instruments. And what can happen is that, particularly if you start back up again and you've got a valve that's almost closed off, the stock will stay behind and the water will move out. And what it will do is it will form what we call a Presto log, which is the kind of thing that you buy in the hardware store and you want to put one on your fireplace or on a campfire or something. And all it is sawdust that has been compacted and it's got a little bit of glue in it to kind of hold it together. And you can take a look at that and just hammer them together and see how hard they are. And that was stock that was sitting in the bottom part of this line here. So if I take this again and you take a look at the size of this piece of fiber, that pipe was absolutely plugged full and we couldn't get it out. it was actually further down the line. If we go right down across the floor here, and Ray, if you follow me,
Yep.
that line there is where that stock comes out, and it goes down this pipe and ends up going down into the stock tank at the bottom. And that length of pipe at the end was where this was jammed. And it was a matter that they didn't shut down properly, and then it sat over the weekend and it dewatered itself. And then we tried to push it out with pressure, and we compounded the problem, and eventually we ended up with these things that were in there, and we had to actually disconnect the piece of pipe, that spool, and lift it up top here and then hammer it out. And these were two of the pieces that got hammered out. Actually, in the bottom of the tank right now, and Ray, if you can just get a picture of that, there is the one batch of stock that we dropped down in here, and it's still below the agitator blade, so there's the main agitators. And probably by the time you get 4 batches in there, then you would be able to start up the agitators. You don't want to start up the agitators now, because they would just spray that stock all over the place. As you can see now, it's splashed all over the inside of the wall. These pieces of metal going across the tank are stays, which are basically there to keep the tank from the top of the tank from wiggling when you got stock moving around in there. So the stays are there as supports. Oh, and lastly, Ray, just come up a little bit. That right there is the radar level transmitter that was measuring the level in this stock tank. So the sequential function chart would not open up the dump valve if there was insufficient room in there. So it's basically interrogating it to make sure that the level is less than 1,500 US gallons. And then we've got room to dump that. Okay, so we've gone through the first batch, and you can see that it's back up at the very top again. It's been up there for almost, well, a little over 5 minutes, because we sort of cleaned up a little bit up there and talked about the pressure log. So Mari, if you would go to the operating screen, please. So now you can see that there's a little bit of stock. And I said there's 200 gallons in there, and it's now telling me I got 197 gallons stock level inside there. And that's from the radar level transmitter. And right now we're sitting at step 1, waiting for somebody to push the start button and make another batch. And as I said, it takes about 8 batches to load this whole process up. What they're going to do next, once they get more stock in here and they get it mixed up, they're going to actually take, and Mari, would you go back to the overview, please? Overview is here. And just hit skip all. What they're going to do is they're going to take stock out of here and circulate it back around into the tank, and then they're going to take it this way, take 37.5 gallons a minute measured by this flow meter right here of water first, and leave the white water valve on manual at whatever position it needs to be to give you 37.5 gallons. Then they're going to open up a hand valve here and adjust this flow control valve a little bit more to get them up to 75 gallons a minute. So we're putting in 37.5 gallons a minute of water and 37.5 gallons a minute of stock at about 3.5%, which is going to make pretty darn close to 1.75 here. Once the system's all loaded up, then this will all go on control. But that's the little formula, and it's in the SOP exactly how to do that to get it roughly at the approximate consistency we want to be at. Okay, that basically covers this part. Thank you. Now we're up at the head box. You see the stock coming in on that line at the back. And then as I rotate it, you see the stock coming across. And right here it's going down the screen. So there's a nip underneath that you can see the stock flowing to, and I'm going to try and move the camera around. So now you can see the stock going underneath the felt and down the head box. And we're running at about 200 gallons a minute right now. The head box consistency control is adding a fair amount of white water to it. You can see the pipe where the stock is going down, gets about a foot from the bottom of the head box, and then it kind of oozes up around the pipe, and then finally starts to flow towards the nip, which is down there. So the stock is going underneath here and then down the felt. There's the head box. See the stock coming down, kind of bubbling underneath the felt. See a little lump go by there. And it's dropping down into the heavy stock tank. Now you get some idea of what 3.5% stock looks like. So the stock is coming up on the heavy line here. This is consistency 510, which is a moving blade transmitter, and its electronics are right up here. And so right now it's indicating that it's not far off set point. It's running pretty close to 3.5% consistency. 50% signal on here is at 3.5%. Pulp stock now goes down the line and comes up to this Zurich involute sensor. And the Zurich involute sensor is pneumatic. I'm going to just open the door. So again, there is the consistency meter, and the consistency meter is running pretty darn close to 9 psi, which is on 3 to 15 is 50%. The Zurich is around the corner, heads down this line here. We have another consistency meter. This is 5.1. This is a scimitar blade. From there, the stock goes down through a pressure control valve, which is located right there, and then drops down that line and ends up going through the floor, and then goes all the way back over into the stock tank, right there. You can see that elbow and then back down into the tank. The stock goes from the 3.5% line down through here, across. There is a consistency meter, or a trans valve right here, 5.5. So that consistency valve puts water in, it goes up to a mixer. Out of the mixer, comes in, goes through another consistency meter. And this guy is a Calais consistency meter turning at 400 RPM. There the stock goes up through a magneter, an E&H magneter, through a flow control valve that's typically running about 75 gallons a minute. And there it goes up, in, and into the stock, or the light stock tank. So I'm just backing out from it. That's the pressure control valve that we're looking at right now, recirculating back up. There is an inline optical consistency meter that is measuring the consistency of the light stock. I go around the corner. We've actually got that consistency meter right there. Tank 5.3 guy right here is actually on load cells, so there's one down here and two more at the back corner, and they go. The 3.5% stock comes along through this line here. There's a pressure transmitter located right there. And then it goes around through a mag tube. It's the part flow 5.7. And right now I'm showing about 89 gallons a minute. The flow then goes up through that line there, through this control valve, which is located right there. Go around that a little bit. So there's the control valve with a DVC 6200 positioner on it. From there it comes along through here, down to there, and the 3.5% stock now comes and meets at 1.75 coming up from here. They go up to a mixer before they go to the total flow line. The total flow comes down through here, and there is a magnetic flow meter right there, an old AC magnetic flow meter, a 50 1/4. There is a smart EEG consistency transmitter back here, which is measuring the 2.65 and controlling the part to total ratio control. We follow this line along further, we come down, and we want to knock the consistency from 2.65 down to 2.2. So we've got two valves, back up here, two valves, split range, and they're overlapped to one another to give a better turn down. There's a turbine flow meter back down in here, measuring the flow of the white water. The white water comes through those valves, mixes with a 2.65, up through a mixer, and then it heads to the head box. Okay, so we've got 2.65 with white water, knocking it down to 2.2. It comes up to this mixer, into this consistency transmitter, the Zurich in volume again, and it's actually an electronic version. It's using 10 to 50 milliamps so that they can get enough force to push the motor back to its position once it's in balance. The output then goes out through a consistency meter, another smart one, measuring the stock going to the head box. From there it goes up through this line, up to a mag meter, which is measuring what the actual stock flow is going up there. Okay, so that's the mag meter right there. And from there it heads to the head box. Okay, now we got it. So what we're going to do is we're going to take a consistency sample from the 3.5% stock. Nick is going to go in and actually start to take the sample right now. You can see the sampler itself down here. And he's going to activate that handle, and then it'll pull stock back. Okay, Nick, you want to go into there, please? So you can see that the stock is being brought in its little sample, and it's getting the right water fiber mixture ratio out of the center of the inlet through the consistency meter. And he's going to basically get about a 1/4 of a bucket. And once he's got that, then we'll go do a consistency test on it. Okay, that should do it. Okay, I got Nick here, and he is actually going to show us what we're doing here. Okay, so he's got a filter paper that he's going to put on and get the weight of. And the weight came out at 1.58 grams, and he's going to write that on the filter paper. Then he's going to weigh the weight of a beaker. And that came up at 17.84 grams. He's going to write that onto his piece of paper. And now he's going to get about 100 ml sample out of the bucket. He's going to mix it to make sure he gets a representative sample of the stock. And then he's going to weigh the weight of the slurry plus the beaker. Then he'll subtract the weight of the beaker from it. Okay, the beaker's gone down on there now. And the weight of the beaker plus the slurry is 138.93 grams. Okay, we're going. So now we're going to take the beaker over to the Bruckner funnel. And he's going to put the filter paper on there, wet it down, and then put it on upside down so that he doesn't lose all the information that he's written on this piece of filter paper. So you can see the filter paper in there now. It's all wetted down in place. Now he's going to take and put his beaker of stock on there. Then he's going to rinse that beaker out into the Bruckner funnel. Then he's going to add water in there just to make the mixture nice and uniform inside the funnel. The water onto the water ejector. The water ejector is sitting right there, and it's going to pull vacuum. You can see the water coming into the Bruckner funnel down below. And if I pull this up on here, you should be able to see the water being sucked out of the Bruckner funnel, and the fiber is now accumulating onto the pad. And in a few moments, we are going to have a pad. You can see now it's drying almost right out. We'll let it suck until it's finished pulling water, and we end up with a dry pad. It's looking pretty dry. So turn off the water. And he's going to use two fingers and kind of peel that pad back. Okay, so we got our dry pad, or pad that's reasonably dry, and the writing's on the back. He's going to go over here to this little heating pad, and he's going to put it in with all the other ones that are in there. And his name is on the back of it, so we'll know whose it is, and now we're going to dry that out. So basically, we'll dry it until the weight actually stops changing, and then we can calculate the consistency from the pad minus the weight of the filter paper, divided by the weight of the slurry. Okay, you've taken the beaker out of that, and multiply by 100. There's your percent consistency. Thank you, Nick.